video, we are going to discuss about the working of refrigerator. Already we discussed about the working of heat engine in previous videos. Now in this video we are going to discuss about the refrigerator. So refrigerator also called as heat pump. Clear? So dear students, as the same, refrigerator also consists of three main parts. One is source that should be operated at the high temperature. In this case it may be atmosphere. And now working substance. Second one is the working substance. So most probably liquid ammonia can be taken as the working substance. And third one is sink that can be operated at the low temperature. So source is maintained at the high temperature T1 and that should be maintained at the lower temperature. Sink is maintained at the lower temperature T2. So children, what we discussed in case of heat engine? In case of heat engine, it is a source and this is the sink and this is the working substance. So from source to working substance, Q1 amount of heat is released, and after doing some work, Q2 amount of heat is given to the sink. Clear? In case of heat engine, what we discussed, the source is at a high temperature, that's why it will eject the heat to the working substance. So from that heat, some part of heat is utilized to do some work and remaining part should be ejected or rejected to the sink. Clear? That means what? Heat can flow from source to sink in case of heat engine. But in case of refrigerator, it is goes in reverse. Clear? So look here, children, there is one diagram, it is there simply for refrigerator. So here this is the sink and that is nothing but contents of refrigerator. Clear? From that heat is going to the working substance, and here source is at less temperature, sink is at less temperature, means what? Cold one, and source is at more temperature, is nothing but hot. In this case, from sink to working substance, heat is going to be supplied. That means what? The working substance, what it is there, that should be collects the heat from where? Sink. Already the sink is at less temperature and the working substance, it is there, what I told you, like liquid ammonia. On that some work is going on, that should be given by the W is equals to Q1 minus Q2. Here what is Q1? Q1 is the amount of heat given to the source. So it means that what, children? The temperature, the heat is moving from here, cold body to the hot body. That means what? Sink to the source. But in case of heat engine, heat is moving from source to sink. Clear? That's why you have to remember, very simple, in refrigerator, the working substance will collect the heat from sink, which is operating at the less temperature. And after that, there is some work is done on the working substance. After that, some part of heat is given to the source like atmosphere. Clear? In this case, the work should be given by the W is equals to Q1 minus Q2. Dear friends, in this case, heat is moving from cold to the hot. That's why some external agents should be required to move the heat from cold to the hot. So that is nothing but the compressors what are available in the refrigerator, they can be acts as the external agent. Why? Because what we know, according to the conditions of heat, it should be transferred from hot body to the cold body only. But in this case, what you have to say, it is moving from cold body to the hotter one. So to move the heat from cold to the hot, some external agent must be required. that should be done by the refrigerator compressor. So this is simply the directions of heat flow and how much work is done on that particular working substance. So now we have to find out the coefficient of performance or performance coefficient. So for that 1 mark should be awarded, children, in the 4 marks question. What is coefficient of performance? Coefficient of performance. So that should be shown by the S symbol beta. Beta is equals to here Q2 by Q1 minus Q2. So beta is equals to what? Q2 by simply what do you write? W. So beta is equals to Q2 by W. Coefficient of performance of a refrigerator is given by the ratio of simply beta is equals to what, right? B2 is beta is equals to Q2 by W. The ratio of what is Q2? Amount of heat absorbed from the sink to the amount of work done on the working substance. Then what, right? Beta is equals to Q2 by Q1 minus Q2, children. So for a perfect refrigerator, so what I told you just now, some external agent is required to move the heat from sink to the source. But in case of a perfect refrigerator, there is no work done. There is no work done to move the heat from sinks to the particular working substance. So simply what, right? For perfect refrigerator, what, right? W is equals to 0. It means that what? Q1 minus Q2 is equals to S 0. And what, right? Beta is equals to Q2 by S. Beta is infinity. Clear? So here what you write? This is the for perfect refrigerator only. So this is the simply about the children working of refrigerator. It is more than enough. Okay. Thank you for watching.